According to the National Electrical Code, specifically Table 310.15b2, ampacity adjustment factors are crucial when dealing with multiple current carrying conductors in a single conduit. In the scenario described, you have 8 lights on dimmers, each requiring a separate neutral, resulting in a total of 16 wires within a single conduit. The question then becomes, what adjustment factor applies from Table 310.15b2? Is it 70% or 50%? The correct adjustment factor is 70%. Table 310.15b2 provides adjustment factors for various wiring methods and insulation types. The key factor here is the number of current carrying conductors. When you have 4 or more current carrying conductors in a raceway or cable, an adjustment factor must be applied to the allowable ampacity of the conductors. In the scenario you describe, with 16 wires in a conduit, we need to determine how many of these wires are considered current carrying conductors. In a standard single-phase circuit consisting of a hot wire, a neutral wire, and a ground wire, only the hot wire is considered a current carrying conductor. The neutral wire is only considered a current carrying conductor if it carries significant current, which typically happens in nonlinear loads like those found in harmonic generating equipment. The ground wire is not considered a current carrying conductor. However, in your scenario, each light has a separate neutral. This means that each light fixture has a hot wire and a neutral wire dedicated to it. Thus, for 8 lights, you have 8 hot wires and 8 neutral wires. In this configuration, all 16 wires are considered current carrying conductors because each neutral is independently carrying current back from its respective light. Now, let's consult Table 310.15b2. This table provides ampacity adjustment factors based on the number of current carrying conductors in a raceway or cable. For 10 to 20 current carrying conductors, the adjustment factor is 50%. Given that you have 16 current carrying conductors, the initial inclination might be to apply a 50% adjustment factor. However, there is an exception to consider when dealing with circuits that serve electric discharge lighting or are derated for other reasons. In such cases, the neutral conductor is considered a current carrying conductor. Since each light fixture has a dedicated neutral wire, each of these neutral wires is independently carrying current. Thus, all 16 wires must be considered current carrying conductors. The dimmer circuits introduce additional considerations. Dimmers use electronic components to control the amount of power delivered to the lights. These components can generate heat and introduce harmonics into the circuit. Harmonics can cause increased current in the neutral conductor, potentially requiring the neutral to be considered a current carrying conductor even in situations where it might not typically be classified as such. According to Table 310.15b2, with 16 current carrying conductors in a conduit, the adjustment factor is 50%. This means that the allowable ampacity of each conductor must be reduced to 50% of its rated value. For example, if you are using a wire with an initial ampacity of 20 amps, the adjusted ampacity would be 20 amps multiplied by 0.50, which equals 10 amps. The question also raises the issue of whether using a dimmer panel would affect this adjustment factor. The use of a dimmer panel itself does not change the adjustment factor derived from Table 310.15b2. The adjustment factor is solely determined by the number of current carrying conductors in the conduit. The fact that the circuit is being used for dimmer lights with separate neutrals does not change the adjustment factor because it does not affect the number or type of wires in the conduit. Dimmers do generate heat due to electronic components and resistive losses, which could raise the ambient temperature inside the conduit. However, Table 310.15b provides correction factors for ambient temperatures higher than 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature inside the conduit exceeds this threshold, you would need to apply an additional temperature correction factor, in addition to the adjustment factor for the number of conductors. In summary, for 16 wires in a conduit serving 8 lights on dimmers with separate neutrals, the adjustment factor from Table 310.15b2 is 50%. This adjustment factor is based on the number of current carrying conductors in the conduit and is not directly affected by the use of dimmers or separate neutrals. However, you must also consider temperature correction factors if the ambient temperature inside the conduit exceeds 30 degrees Celsius or 86 degrees Fahrenheit. Always consult the latest edition of the National Electrical Code and consult with a qualified electrician to ensure compliance with all applicable codes and standards. To recap, let's address the question directly. You have 8 lights on dimmers, needing separate neutrals but on the same circuit off a dimmer panel, resulting in 16 wires in a pipe. The adjustment factors from table 310.15b2 work with a 50% adjustment. The presence of dimmers and separate neutrals does not change the fundamental requirement to adjust ampacity based on the number of current carrying conductors. Always ensure that your wiring and circuit design comply with the National Electrical Code and local regulations. This ensures the safety and proper operation of your electrical system. Remember to account for both the number of current carrying conductors and any applicable temperature correction factors to determine the final allowable ampacity of the wires in your conduit.